Hi everyone, it's Rahman Khan from RMK Six Sigma, bringing you another episode where I go through a worked example from my book Six Sigma Statistics using Minitab 17. Okay, so even if you don't own the book, you can still download the data set we're going to be going through from my website rmk6sigma.com. If you like what you see, please hit the thumbs up or subscribe. In this video we're going to be looking at the two sample t-test, and we're going to be using data from example 7.6.1. So the two sample t-test is probably the most widely used test in Minitab, and the reason for that is that it compares the means of two independent populations. We're going to be looking at the test using the assistant rather than the classic menus, and the great things about the assistant is that you get those great reports, and also for this test you don't have to worry about equal variances like you do when you use the classic menus. Okay, before we start, let's have a quick look at the requirements for the test. So for a sample size we need 15 data points from each group for the normality of the population that the samples are drawn from not to be an issue. Okay, we may need more samples if our power is low, and it depends on the difference that we want to be able to detect as well. Okay, so we need continuous data that's time ordered from a unimodal distribution, and the data must be stable. Okay, as I said, the example that we're going to be looking at is 7.6.1, and I'll just read the example scenario out. ICRA works for a famous chocolate bar manufacturer and wants to find out which of two factories has the highest sugar yield. She takes 62 random samples from each factory and analyzes them for sugar content, and then knowing the sugar that went into each bar she can work out the sugar yield. So help ICRA work out which factory has the highest sugar yield. I've already downloaded the data and put it into Minitab. So the two factories are called Phobos and Demios, and we have 62 data points from each factory. To bring up the test menu, I click on Assistant, Hypothesis Tests, and then I need to go to the middle group and select 2 sample T. Okay, so that's the menu. So first of all we're asked whether each sample is in its own column, and it is, so we need to select each column separately. So I'm going to select Phobos first and then Demios secondly, and then the test setup, which has to do with whether it's a one-way test or a two-way test. In this case we just want to know whether one factory is different from the other, so we're going to click on the bottom radio button as it's a two-way test. We're happy with the alpha level, which is the default value, and the difference that we want to be able to detect, even though it wasn't stated in the question, we're going to be looking at 1% difference in sugar yield as the minimum effect that we want to be able to detect, and that will help us work out the power and sample size for the test. Okay, so I'm going to click on 1 there, and then click on OK to execute the test and produce the 3 reports pages. So here we start off with the summary report, which gives us the answer to our investigation statement. So do the means differ? And we have a p-value which is below our significance level, and the p-value is 0.019, less than 0.05. So yes, we have detected a difference between the two groups. We then get the 95% confidence interval for the difference, and we can see that 0 is not within the confidence interval. Then we get a histogram for Phobos and Demios, and we see each of their confidence intervals, and they do slightly overlap, but still the groups are deemed to be different. Here then we get the individual sample data, and as I said, we can see that the confidence intervals do slightly overlap. So the high end of Phobos is 87.8 and the low end of Demios is 87.57, so there's a slight overlap there. However, Minitab calculates the confidence interval for the difference to be anywhere between negative 2.32 and negative 0.215. So it's saying that Phobos has a lower yield than Demios. Okay, let's have a look at the diagnostic report now. And again, the diagnostic report is there to tell us the reliability of our test. We have our 2 control charts to start off with, and it says on the outliers are marked in red. We don't have any outliers in our data, which is slightly unusual, but we're okay with that. So we can then look at the power for the report. Okay, now there could be an issue there. So we have a power of 46%. However, the test has detected a difference, so we don't really need to worry about the power. However, had it been the other way round and we hadn't detected a difference, we would have wanted to rerun the test again with more data to ensure that we had a higher power. And if we had rerun the test to get a power of 90%, we would have needed 187 sample points in each group. But like I said, we don't have to worry about that because the test detected a difference anyway. So then finally, let's move on to the report card. And I'll just bigger that. Okay, so the report card tells us how reliable our test was, and it checks for unusual data. It says great, got a tick for that. There are no unusual data points. Checks for normality. It says okay, great, because you had more than 15 in each group. The normality of the populations that the data was drawn from is not an issue. And it says sample size is good as well, because we detected a difference and we didn't have to worry about the low power. And again, we're told there that the assistant uses Welch's method rather than the method used in the classic menu where you have to worry about equal variances. Okay, so that rounds up the 2 sample t-tests. For more examples, please have a look at my book, Six Sigma Statistics using Minitab 17, and there's also some good exercises for you to do on there. Thanks, see you next time.